Far millions of kilometers from Earth, storms rage that can engulf entire continents. Gas whirlpools conceal ancient secrets, and beneath the cloud layer lies the past of the entire solar system. But humanity has sent a scout there. It rushed through radiation belts, approached the most dangerous zones, and peered into places no spacecraft had reached before. Its mission uncovered the unexpected, challenging our understanding of giant planets. But what exactly was discovered? What findings became a sensation? All the most important details are right here. Like and subscribe so you don't miss the main news. The NASA spacecraft Juno was launched on August 5, 2011, as part of the New Horizons program to study Jupiter. Nearly 5 years later, on July 5, 2016, it entered a polar orbit around the gas giant, becoming the second spacecraft in history to reach its vicinity. The first was the Galileo spacecraft, which studied the planet from 1995 to 2003. However, Juno became the first to have the opportunity to study Jupiter in detail from a polar orbit. The main goal of the mission is to investigate the atmosphere, magnetic field, and magnetosphere of the gas giant, analyze its internal structure, and create a wind map. How has the mission's extension changed the prospects for its scientific discoveries? NASA extended the mission of the Juno spacecraft, which is studying Jupiter, after technical difficulties affected its original plan. Initially, the spacecraft was supposed to complete its mission in February 2018, with its scientific phase lasting only 14 days. It was planned that Juno would transition to a short 14-day orbit after completing its initial 53-day orbit. But this maneuver was never carried out. During checks, it was discovered that 2 helium valves in the fuel compression system opened with a delay of several minutes instead of the required seconds. This posed a risk of unstable engine operation during orbital changes. As a result, NASA decided not to perform the maneuver to avoid potential damage to the spacecraft. Because of this, Juno remained on its extended 53-day orbit. Instead of the planned frequent observations, scientists had to adjust their research strategy to accommodate the new conditions. However, the spacecraft continued to transmit valuable data on Jupiter's magnetic field, atmosphere, and storm dynamics, significantly expanding our understanding of the gas giant. Recognizing the importance of the mission, NASA extended it further, and despite changes to the flight plan, all scientific instruments continued to function properly, allowing Juno to fulfill its tasks. What unexpected discoveries were made during the Juno mission? What unknown geological processes might be triggered by massive volcanic eruptions on Io, and how do they affect its atmosphere and surface? The lead researcher of the mission, Scott Bolton from the Southwest Research Institute in San Antonio, noted that each of Juno's close flybys provided unexpected data about the moon, but the latest, more distant flyby stunned scientists. He described the event as the most powerful volcanic phenomenon ever recorded on Io, the most volcanically active moon in the solar system. Io, the size of Earth's moon, is located very close to Jupiter. Its elliptical orbit causes the moon to complete a full orbit around the planet every 42.5 hours, and the variations in Jupiter's gravitational pull create strong tidal forces on the moon. This generates immense energy within Io, leading to constant lava eruptions and ash plumes from the approximately 400 volcanoes covering its surface. GRAM, originally developed to study Jupiter's atmosphere, was repurposed to observe its moons after the mission was extended. During the extended mission, Juno flew close to Io twice, capturing changes on its surface. In December 2023 and February 2024, Juno passed 1,500 kilometers from the moon, and in December 2024, it flew at a distance of 74,400 kilometers, directing its spectrometer towards Io's southern hemisphere. The GRAM instrument recorded extreme infrared radiation, indicating the presence of a hotspot so powerful that it overloaded the detector. According to Alessandro Mura, a co-investigator of the mission, this is likely several hotspots erupting simultaneously, which may suggest the existence of a massive underground magma chamber. The scientific team estimates the hotspot spans about 100,000 square kilometers, 5 times larger than the Loki Patera lava pool, which was previously the largest volcanic feature on Io. Images from the Juno camera taken in 2024 also revealed significant changes on the surface of the Moon near the South Pole. Despite the low resolution of the latest images, they clearly show changes in the surface's color, indicating active volcanic activity. Eruptions of such magnitude leave long-lasting marks, including pyroclastic deposits, lava flows, and sulfur deposits, confirming the prolonged impact of volcanic activity on Io's geological structure. What secrets does Jupiter's atmosphere hold? How has Juno's record-breaking flyby influenced our knowledge of gas giants? Thanks to the Juno spacecraft mission, during its 38th orbit around Jupiter, the world received unique images of the gas giant. These impressive images were transmitted to Earth from a record distance of 780 million kilometers. It is important to note that due to the intense radiation coming from Jupiter, the spacecraft had to adhere to strict safety protocols, performing precise maneuvers and avoiding excessive proximity to the planet. However, despite these restrictions, Juno was able to approach Jupiter at a record distance of 4,200 kilometers. This allowed for unprecedented detail in capturing clouds, powerful cyclones, violent storms, and the northern part of the planet. Could the concentration of water in Jupiter's atmosphere hold the key to unraveling the origins of the solar system and its first planets? Why did the Galileo spacecraft's data on water in the atmosphere of this planet raise so many questions? And what new insights has the Juno mission uncovered? The Juno spacecraft has provided new data on the water content in Jupiter's atmosphere, which significantly differs from the results obtained by the Galileo probe in 1995. At that time, the probe penetrated to a depth of 130 kilometers and recorded unexpectedly low water levels, leading to the hypothesis of the existence of wet and dry zones in the planet's atmosphere. However, Juno confirmed that there is much more water present than the Galileo data suggested. According to Juno's findings, at Jupiter's equator, water makes up about 0.25% of the total volume of atmospheric gases, nearly 3 times the concentration of oxygen on the Sun. This confirms that the gas giant's atmosphere is heterogeneous and that the element content in its various regions differs substantially. Studying the water in Jupiter's atmosphere helps us understand how the solar system formed. Jupiter is the first and largest planet, having captured a significant portion of the gas and dust that remained after the Sun's formation. Analyzing its atmosphere allows us to study the properties of planetesimals, the bodies from which the planets were formed. The mission of the spacecraft Juno continues to unveil many astonishing facts about the gas giant. The conducted research has led to a re-evaluation of many previous hypotheses. Despite the technical challenges faced by the mission, it continues to make groundbreaking discoveries. The study of Jupiter by the Juno spacecraft will continue until September 2025, or until the end of its operational lifespan, revealing even more secrets about the giant planet. Stay updated on new discoveries, subscribe to the channel, and follow the news.